Hi, fourth grade. Today in math, we are going to look at lesson 512. It is all about symmetry. But there's an extra part at the end that is about pounds, ounces, grams, and kilograms. So we're going to start with a little refresher there. If you don't remember how many ounces in 1 pound, go to the front of your math journal and look inside. There is a conversion chart. So let's do a couple of these together, and then you will finish them on your own. How many ounces in 1 pound? If I'm looking inside, I'm going to see that there are 16 ounces in 1 pound. Now I'm going to do a little multiplication. I'm going to do 16 times 4. And when I do 16 times 4, what do I get? 64. I want you to do the same thing for 10 pounds, please. When you're finished, pause this. When you're finished, let's go on to kilograms. So how many grams are in 1 kilogram? Kilo, what does that mean to you? Kilos are big. There's 1,000 kilograms in 1 gram. This should sound familiar with meters, liters, the word 1,000. So how many grams are in 1 kilogram? I'm going to click in here. I'm going to write 1,000. And there we go. We have 1,000 grams in a kilogram. So to figure out 18 kilograms, I'm going to multiply 18 times 1,000. And I get 18,000. Please do 3.5 on your own. Today's lesson focuses on symmetry. Symmetry, I'm sure you've heard that word before, but let's refresh ourselves with some vocabulary. A shape is symmetric. That's an adjective, a describing word. It can be folded in half along a line. So the two halves are the exact same size and shape. We have some examples up here. I have a square, and see my dotted? That is my line that we're referring to. That breaks it into 2 even pieces. That fold, that line is called a line of symmetry. Remember, it is a line of symmetry. Now, the word mirror image, which is our next one, means it's the exact size and shape, but it faces a little bit different direction. So if I'm going to look here, I have my star, and look where my point is on this side. The exact image on the other side, but it's going the other way. That's what we mean by same size and shape facing in the opposite direction. You can also notice that with my triangles facing this way, and it's facing that way. Let's continue. Please open up your math journal to page 184. I'd like to do a few of these together. It's really helpful that they give us this dots so that we can count properly. So if I look and I want to do something the exact same on the other side, I notice that I have a line that goes from the top corner diagonal to the middle. So I'm going to go from the top corner diagonal to the middle. And then I notice it goes straight down from dot to dot. Dot, dot. Can you pause and then try number 2? Number 2, what letter do I think that might be? Let's find out. So I go from my line of symmetry and I see it goes directly up to the next dot. So if I flip it down, I go from my line of symmetry straight down. I notice this one also goes from that same line of symmetry, the dot that goes through there, and it goes at a diagonal. And there we go. Good job. Please answer questions 3 and 4 on your own. 5, 6, 7, and 8 are just a little bit different. They're not letters, they're shapes. So you have to do some more counting. So my first one is over 1, down 1. So I go over 1, down 1, and I can connect my dots. Then I know I need to go over 1 and down 1, over 1, down 1. Do you see how I'm figuring out where these dots go? And then I go down 1 and in 1. So I go down 1, in. And again, down, in. For a shape like this, it doesn't seem like too much of a big deal to count those dots. But when you do number 7, And number 8, it's very helpful. So go ahead and pause this video, answer question number 6, and then together we will do question 7. All right, so now you've answered 6, so let's go ahead and do question 7. So I start from here, and I go over 1. So I'm going to start from the middle again. I'm going to go over 1. Now I'm at my top. I'm going to go diagonal to the center line, to that line of symmetry. So I'm going to go diagonal to that line of symmetry. I'm going to start here, and I'm going to go over 1, 2, and down 1. So I'm going to go over 1, 2, and down 1. And I know that I'm going to connect my line. My lines aren't perfect. Yours won't be perfect unless you use a ruler either. Then I'm going to go down 1 and in 2. Down 1, in 2, and connect my dots again. Now I have one more. I'm going to go, I'm in the middle. I'm going to go down 1, out 1, down 1, out 1, and connect my dots. And lastly, I'm going to bring it all back to the middle. Go ahead and pause this video and answer question number 8. If you want to challenge yourself, go ahead and answer question number 9 and number 10. Draw in those extra lines of symmetry. This is a good challenge because there are what are called quadrants, 4 different spaces. 1, 2, 3, 4. And you'll notice there are 2 lines of symmetry. So do one part at a time and see what you can do. I want to spend the last bit of our time on doing some of these word problems. This is where we're going to get a little bit more challenging. So we have this Millman's family, and they had a baby, and the baby weighed 6 pounds and 7 ounces. The Chan family had a baby, and their baby weighed 7 pounds 6 ounces. And I want to know how much more did the Chan baby weigh than the Millman's baby. So I'm going to look for some keywords, or numbers that would help me. So I know that the Millman's family weighs 6 pounds 7 ounces. I'm sorry, and the Chan baby weighs 7 pounds 6 ounces. And my keyword is many more. That's going to tell me I need to subtract. So I'm going to subtract my bigger number, 7 pounds 6 ounces, and my smaller number, 6 pounds 7 ounces. And if you'll notice, we're working in pounds and ounces, and that should look familiar from what we did at the very beginning. So I'm going to go to my numbers now. So I have 6 and I have 7. I can't do that. My 7 is bigger than my 6. Well, what am I going to do? I need to borrow. Everyone knows we need to go and get some from the other side. So I'm going to take 1 away, and that becomes a 6. That's perfect. But when I bring it over, I'm working in pounds and ounces. So if you think back to our time of fractions, when you brought over a whole, you had to think of it in the terms of that denominator. We today have to think of it in terms of pounds and ounces. So if I bring over 1 whole pound, how many ounces is that? 16. Ounces equals 1 pound. So I'm going to add 16 ounces to my 6 here. And what do I get? 6 plus 16 is 22. That's my new number. So I'm going to write 22. Now I can subtract because 7 is smaller than 22. 22 minus 7 is 15. And yes, I'm going to write both digits on this side. Then 6 minus 6 is 0. So the question is, how many more ounces did the Chan baby weigh? I look for my ounces because this is my ounces column, and I'm going to fill in 15. Okay, I want you to try question 2 on your own. All right, so let's see how you did. I've already highlighted some of the most important information that I found when I was reading this problem. A ream of paper weighs 5 pounds. One school ordered 125 reams. Another school ordered 140 reams, but I want to know how many pounds these reams weigh together. Together is my clue word here, and that tells me I'm going to add. But I want to know how many pounds they weighed. So if I have 125 of them, each weighs 5 pounds, that tells me I need to multiply. So 5 times 5 is 25. I'm going to carry my 2. 2 times 5 is 10 plus 2 gives me 12. I'm going to carry my 1. 5 times 1 is 5 plus 1 is 6. Now I'm going to do the same thing for 140 reams for the Fitch school. 5 times 0, 0. 5 times 4, 20. Put down my 0, carry my 2. 5 times 1 is 5 plus 2 is 7. So now I know how much the Blaine school's paper weighed and the Fitch school paper weighed, but together I need to do one more computation. So 700 plus 625, and that equals 5213. 1,325 pounds. You ever heard it said 1,325 pounds? That is one way of doing it. Please try a couple more problems on your own. If you have any questions, contact your teacher. Have a good night.